Okay, folks on the, Kevin, are you still on the phone?
I am.
Can you see my slides?
I can't. Well, now I can, yes.
Excellent, okay. All right, so as I said, we're going to pivot now. You just heard a great presentation on Climate Change 101, kind of from the global story, what's happening globally, and telescoping to local water resources impacts in the Northwest. Now, I'm going to try to put this more into a reclamation context. And Jennifer, she helped me develop these slides, as did Carrie Hessman. Both of them stepped out of the room. Wanted to thank them. Recap of talk number one. These are some of the headlines from the third U.S. National Climate Assessment that Kevin referenced. And I paraphrased the top bullet a little bit, that throughout the West, we're going to experience challenges as water, energy, and challenges are going to vary by region and the types of climate change by region, but all of those natural resource management groups are going to have challenges. So a preview of the key messages that I'd like you to walk away with from this second talk are listed here. I have three. So the first is, we have always dealt with climate variability. I mean, Reclamation is an agency born to deal with the climate variations of the West, from floods to droughts, and apply water resources to societal needs, but also in an environmentally and economically sound manner. So our challenge going forward is, how do we prepare for potential drift in climate variability? So climate variability will always be present. It's just we're concerned about a drift. And when we see a drift, we're talking about preparing for a future with different floods or different drought expectations. How does that translate into different supplies and demands that have to be balanced? How does that factor into managing for environmental stewardship? You know, the climate variations are an important consideration there. And also on how do we manage infrastructure and dam safety under changing climate extremes? So that's the first question. How do we deal with potential drift in variability? Second, management of water and related resources involves many considerations. It always will, always has, always will. Climate change is just one more uncertainty. It doesn't sideswipe all the ones that have been there. It's added to the mix. This is one more uncertainty to consider. Third, our response to the challenges posed by climate change. It is about preparing for the future and factoring climate change into our traditional approaches for planning, conservation, operations, science, et cetera. It is about different communities within Reclamation communicating with one another about their approaches. It is not about abandoning all the good things we've always done and replacing them with some reinvented way to manage water and related resources. It's about flexing what we've always done, making room for a new uncertainty, and just learning how to deal with a new uncertainty. So that's the preview. I'll hit those messages again at the end. So as we all know, the mission of the Bureau of Reclamation is to manage, develop, and protect water and related resources in an environmentally and economically sound manner. I'm introducing some terms for this presentation. Conducting our mission requires different areas of activity, where each area features a unique management approach carried out by a unique community of practice. So within Reclamation, we're really kind of a family of communities, and each community has their own people, their own lingo, their own methods, business practices, et cetera. So climate change, it has tentacles to each of these communities. That's what I'm going to try to illustrate with this talk. So the outline is to highlight implications of climate change for different mission areas, highlight which types of climate change may matter most to management within a given area, and to help orient your minds on making your own judgments about what types are most relevant, matter most. I'm going to try to get you to think about relevance to your decision making and also reliability of the information. And third, provide missionary communities insight on where they have common concerns and where they might be motivated to communicate across communities. So the 5 communities that I'm going to be focusing on in this talk, it's not an exhaustive list in Reclamation, but it's representative of the diversity of the types of communities we have. So I'm focusing on infrastructure management. These are the folks that plan extraordinary maintenance projects, major repair and replacement, like say a turbine runner replacement at a dam, something that gets maybe done once in a generation. These are major infrastructure changes or new infrastructure development, but focusing more on the infrastructure replacement and upgrades. Second, dam safety. Third, species recovery and adaptive management. Fourth, long-term planning. And fifth, reservoir operations, the folks that are making day-to-day, week-to-week decisions on reservoir storage targets and water release targets. So each of these 5 communities must ask, how do we prepare for potential drifts in climate variability that matter to that community? Or deal with, and if you don't want to worry about climate models and future projections, you can just ask the question, how do we deal with apparent recent drifts, observed changes in the recent past? Second, what kinds of future weather and hydrology conditions should we expect going forward, for both averages and extreme conditions? And third, for what geographic areas and what conditions timeframes? So what do I mean by those latter 2 questions? I'm going to kind of walk through some examples. So for hydrology and weather or hydro weather conditions of interest, you might start with air temperature. So we're interested in local air temperature trends from the past and expected changes in the future. As air temperature changes, you might expect less snowfall, more rainfall. So with changing snowfall or changing retention of the snowpack during the spring as air temperatures warm, that's going to affect stream flow patterns, timing through the calendar year. It's going to affect water supply availability through the calendar year. Also, air temperature, it's one of the ingredients to evapotranspiration or loss of water from vegetation in the landscape. So as air temperature increases, it promotes more loss of water through ET. So all that could combine to affect drought possibilities. Air temperature increase is linked to water temperature increase. That has implications for aquatic resource management and riparian habitat management. Could be connections to water quality, other changes in other water quality constituents as well. In parallel to air temperature, we're also concerned about changes in precipitation patterns that are responding to the kind of the global climate change story. And as we discussed during talk 1, warmer air can hold more moisture, so that's one of the ingredients for heavy downpours. It's certainly not the end-all be-all for big storms, but it's one of the ingredients to be aware of. That could be one reason why we might see changes or anticipate changes in heavy storms. And then closely linked to heavy downpours and big storms are associated floods. But floods, of course, are mitigated by watershed conditions as well. So they're an uncertain outcome, but one of high impact, so we give them a lot of scrutiny. So that's just giving you a sense of the types of changes that might be of interest to your community. Second, over what region are we talking about? You could be interested in large regional average climate change as it affects large regional resource conditions like say Columbia River runoff at the Dalles, which is going to be reflective of climate change in the entire Columbia Basin and the Upper Snake. Or maybe you're just focused more on a reservoir basin and you're doing resource management or planning just in one watershed, so you're concerned more about the expected climate change over just that basin. And then lastly, maybe you're concerned more about local catchment, like maybe you're doing river reach actions in an environmental management program, or you're concerned more about agricultural irrigation demand conditions over a district area or field. So think about the geographic range of areas of interest. And lastly, condition timeframes of interest. You may be what I'm getting at here is, are you interested in changes in weather event phenomena that play out over hours to days? Or are you interested in change in season condition, like is it a dry spring season or a wet spring season? Or are you interested in changing a water year or changing a spell of multiple years? So you have to kind of also think about the condition time frame that's relevant to your management and planning decisions as well. And there's a lot of options here, and you're seeing slides coming ahead that you're going to maybe just focus, try to separate the wheat from the chaff and focus on what's the most important stuff for your management. So climate change, it involves many types of changes: hydroweather conditions, regions, conditions, time frame. Missionary communities, as I said just now, must decide which types are most relevant to their interest, and we'll walk through all 5. This is kind of the high-level start preview. And then after, in parallel to deciding which types are most relevant, also judge what information on observed change and expected future change is reliable enough to warrant some kind of action. And I'll pause on that. So warrant some kind of action, there's actually a range of actions. So the lowest level, lowest risk action is you're just accessing this information on observed change or information on future change, and you're trying to orient yourself on how to use it. So it's an internal exercise. Maybe a next level, you're feeling like it has some compelling qualities to it. Maybe you communicate potential vulnerabilities to your resources, like an impacts assessment. But it's not a decision support exercise. Maybe a level beyond that, you think it's compelling enough to warrant some preliminary adaptation planning, some develop adaptation strategies. And beyond that, maybe you feel like it's really actionable and it should be bearing influence on investments you're making today that have long life. So there's really this continuum of potential warranted action from low risk to really leaning forward. And you have to kind of make that judgment. And that's going to vary from community to community and region to region. Okay, so that's the kind of the high-level preamble. Now I'm going to walk through those 5 communities and step down a level of detail. And with each community, I'm going to try to describe what I think you guys do in that community. So hopefully I have people on the phone or in the room that are from each of these 5 communities that can raise their hand and keep me honest. Am I doing this right? So first I'm going to start with long-term planning. Who in the room would say they work on long-term planning studies, whether it's appraisal level or feasibility study or NEPA? So we have some hands raised. This is good. Okay, so with this community, what I'm focusing on, they do a lot of things, but just the set of things they do that I'm focusing on here is they evaluate proposed actions on our systems, whether it's change in infrastructure or change in long life operating criteria or management rules. And they look at the benefits and the effects of these proposed actions or changes. So these actions, it's a broad set of possible actions that they get evaluated. But some of the types of studies that this community undertakes are listed under study types. One level you'll hear about is an appraisal level. That's kind of an exploratory level study where you're looking at, it's an initial look at benefits, and I'm not sure if environmental impacts are looked at in appraisal level. I'm looking to anyone. Not really. Identify, but not inspected too detailed. So it's really a kind of a shallow look at the potential benefits and issues with a proposed action. And then the feasibility study would be the deeper dive look. And the big thing with the feasibility study is that at the end it's supposed to support a recommendation on whether to invest in the action or not. And in parallel, so the feasibility study is going to be a more detailed look at benefits and costs. And also in parallel, it has to have associated environmental compliance done, which is some NEPA type of a document, whether it's an environmental assessment or environmental impact statement. I'm getting general head nods in the room, so dismount is adequate. So an example type of a long-term planning study. It's a basin study supported by the Water Smart program and involved federal and non-federal support. Sorry, no, I backed that up. There's a series of studies that happen in the Yakima River Basin. I should hand this over to Jennifer, and she could explain this a little bit more deep.
And I should probably hand it to Ken.
Or you could start just with the basin study.
So listed on this slide is really the history of the Yakima River Basin Water Enhancement Project. It's commonly referred as YRWEP. And so what is listed on there is how YRWEP has developed over the last 30 years. And so what I'm going to jump to is, rather than repeating what's on the slide, I'm going to jump to what we're doing now, which is called Phase 3. And that is what most people have heard, which is the Yakima Integrated Plan. And so with that, we're actually in the kind of the deeper dive look We've gone through all of these steps, and what we're doing now is we're actually performing some environmental impact statements on proposed actions. We're looking at feasibility studies for other actions, and so with that, what they've done, and I did skip over the basin study part. Sorry, the basin study did precede those deeper dive projects. They did an extensive amount of climate change analysis in there, and then in the project specifics, they've still done some additional climate change analysis, because of those projects, one of them is a pool raise, a 3-foot pool raise, and so the what it's doing is looking at water supply and fish benefits, because as we're seeing this year, which is a good example of, I've heard it from the 2030 projected period and even out to the 2070s projected period, that we're seeing the examples, and they've been really challenged with maintaining an adequate water supply for irrigation. And so this is a good example of how, over time, though it's 30 years ago, we weren't really calling it climate change. We've been planning for that long-term planning, and this isn't unique to our region, but this is just one example.
Great, thank you, Carrie. Put my mic back. So just to quick recap, that recently a basin study or appraisal level type study was completed that identified a number of adaptation strategies, and there's been more detailed look, but some of these are long life strategies, whether it's new infrastructure or management rules that are going to have long life. So that's a good example of a series of long-term planning efforts in one of your Northwest basins. So back to the generalities of how this community might approach climate change, and I'll pause and say, actually in the Pacific Northwest region, I kind of built this slide for one size fits all for all 5 regions, but in the Pacific Northwest, there's been a long recent history of trying to make use of climate change information in long-term planning. So you guys are kind of hitting the ground running with this community. But they focus on what future climate possibilities might be and what they might mean for future water supplies, water demands, and conceptually, they could also look at the different types of management constraints on how we manage water resources. Like one type of constraint that I'll talk about more with Reservoir Operations is storage reservation diagrams at reservoirs. We get asked questions, okay, if snowpack is diminishing, if spring runoff is occurring earlier, should we rethink what these calendar rules of how deep we need to draft reservoirs to make space available for flood control. And there's other types of constraints as well that could be climate sensitive. On the left, what I'm trying to draw attention to are the types of hydro weather conditions, regions, and condition timeframes that are likely relevant to this long-term planning community. The solid outlines mean likely relevant, and the dashed outlines are just my opinion about other conditions that may be relevant, but probably less so. It's going to be more case by case, not always as common from study to study. But you guys may disagree, but it's kind of to spur thinking. What's likely to be more relevant, more common in these studies, what's going to be more spotty. In considering climate change for this community, there's a couple points of view where climate change may on-ramp into the study forum. One is more from the water smart basin study view. Is future climate change one of the motivating factors for considering or identifying potential actions? So a water smart basin study, you'll see more information on that in a bit. It's supposed to define future supply and demand conditions under climate change and under other future stresses. Then it's supposed to involve a gap assessment or a vulnerability assessment of managing through future supply and demand conditions where there are gaps. And then lastly, it's supposed to include development of adaptation strategies to close those gaps. On the other hand, and probably more common, is you face present-day water management challenges, and people like in the Yakima Basin, they have present-day water management challenges. And so a lot of these solutions are being proposed to relieve issues today, but the solutions just happen to have long life. And because the solutions have long life, that's why climate change is relevant to the consideration of those solutions. And the last point, estimating future climate possibilities, it's an uncertain activity, so invite the invitation to this community is to focus on risk-based planning, consider a range of future climates, and if you connect with folks in the PN region who have stepped out and considered climate change and long-term planning, you'll see that's kind of how they've approached it. Moving on from long-term planning, we can always come back to. I'll go to the second community, infrastructure management. Do we have any folks in the room who work on extraordinary maintenance or major repair replacement type projects?
Actually, Mike does, but he just stepped out.
Just stepped out.
He works at our Anderson Ranch Dam facility.
Do we have any folks on the phone who work on extraordinary maintenance?
They may be muted.
Probably all busy working on that.
Yeah, you're probably right, and that's a good thing. Well, anyway, if anyone is on the phone and works on this and I misstate this, please speak up and we'll get this clarified. But really generally speaking, this infrastructure management community works on a lot of things, but what I'm focusing on here today is when they develop projects that involve, like I say, once in a lifetime kind of upgrades to major infrastructure installations. So like a turbine runner replacement, for example. These types of projects take a while to develop, sometimes over a year to develop. And when I mean develop, I mean like pre-design and design. They're replacing really old equipment and trying to take advantage of new technology. And also, these are expensive projects, and we have small wallets. And so then the annual prioritization, we go through a process of picking and choosing what are the highest priority extraordinary maintenance projects that go forward in a given year. And that's going to vary with region needs for that, in that pulse check in that given year, cost share opportunities, other factors. So to date, up to this year, the consideration of climate change has really not been present throughout Reclamation. But in FY15, Reclamation received appropriation to begin developing and adding a climate change criterion to both of those stages in this extraordinary maintenance process, both the project development stage and also that project selection prioritization stage. And I'm going to have more slides on that in Talk 3, but just this is the kind of business process I want you to focus on with this community here. So this infrastructure management community, the types of climate-related assumptions that might be most relevant to them, clearly it's going to vary by facility, but you can imagine you want your infrastructure to be able to handle extreme conditions reliably. So you care about wet side extremes, heavy downpours, floods that need to be passed by facilities, but also dry side extremes. An interesting example in the lower Colorado region is after years and years of experiencing a pretty good dry spell or a drought in the Colorado Basin, they spec'd a turbine runner replacement at Hoover Dam so that it could operate under a wider range of pool elevations, particularly lower pool elevations, just anticipating that they might have more frequent droughts in the future. So that's something where recent drought experience and concern about future climate change qualitatively influenced speccing of a project during project development. Other thoughts there are based on preliminary conversations with George Gurgis from the TSC Infrastructure Services Division and Martin Bauer from Policy and Administration's Asset Management Division. They're both working on this FY15 initial effort. That they brought up that I hadn't thought of is water quality concerns, particularly related to corrosion. Not so much because of temperature change, but they're wondering about as carbon dioxide concentrations increase, will that affect the acidity and the pH of water? Will that enough to maybe warrant some different thinking about coatings or other types of protections for underwater infrastructure installations? So in considering climate change, this community is going to be challenged to pay attention to observed historical trends and also pay attention to projected future trends during the service life of these replaced infrastructure installations, and reconcile that historical and future view. And also this design community is going to be challenged with a risk-based situation where there's a range of future climate possibilities. They need to design to a certain level. How do they design within this wide cone of future climate possibility? That's another challenge for this community. We'll move on. to a third community here, species recovery and adaptive management. Who in the room would say they work on species recovery issues? Great, we have a few people. So again, keep me honest. So PN region is like other reclamation regions. You have several regional programs that where the goal is to recover threatened or endangered listed species. And we can focus on aquatic species here just as an example. These programs deal with unique species, unique recovery goals. Often there's unique threats that are obstacles towards that pathway to recovery. It's going to vary program by program. Also, the human side, there's different coalitions of the willing in these programs, and different stakeholder groups and different resources. So each program's a unique animal, very diverse, very complex. But one common theme across these programs is they all are managing in the face of large scientific uncertainties. We don't know all that we would like to know about the species we're trying to recover. We don't know all that we would like to know about these environmental threats or competing species or whatnot that limit recovery. So one approach in dealing with that kind of management under uncertainty is kind of learn as we go. Lean forward, do some actions that we think will be beneficial, but monitor and see if it's successful and do course corrections. And a formal view of that is adaptive management. And I know that adaptive management formally is not present in a lot of our programs, but you could probably argue that some of the concepts, at least in an informal way, the learn as we go, course correct is kind of present. I'm looking for some head nods or disagreements, but good, head nods, excellent, good. So this community, they have an interesting situation as far as what types of climate changes might be most relevant to them. Well, they have the species relations with climate, but also all the habitat relations with climate, the threats relations with climate. All of those could be relevant starting points to begin answering what's relevant. So you might start, I just listed here, you might start with thresholds related to habitat quality or species health. And you might anticipate that the full range of hydrologic conditions from dry side to wet side could be relevant, especially the extremes. And probably interested in water quality, whether it's water temperature or other constituents. But program by program, you have to make that judgment of what types of climate conditions are most relevant to the species, the habitat, the threats, et cetera, and then judge which changes in those types of climate conditions are going to be most relevant. And then on considering climate change, a couple, cautionary notes. While your activities in the program may be more at the river reach scale, like you're improving habitat in a given reach of the river, you may find yourself needing to consider climate conditions and change over a larger basin or watershed scale. So there may be a mismatch of where your management's occurring and the scale at which you need to consider climate. And then second, adaptive management may take a very long time. Like I know salmon, what's the life cycle of salmon, average life of salmon, like several years? 5 years? I mean, other programs in reclamation, they're dealing with fish species that live decades. Yeah. So, and they're trying to restore populations. Think about how many generations of the species that you're trying to recover, how many generations reasonably needs to occur before you can expect to see a trend and understand that that's probably occurring in the context of a drifting climate. So drifting climate is just one factor that needs to be kind of kept in mind as you're interpreting these species trends and recovery pathways. Okay, moving on to the fourth community, dam safety. Who here works on dam safety issues or studies? We have at least one. Hopefully some folks on the phone. So with dam safety, I'm going to draw attention to their risk management process, which I think is an excellent process. It's been, in place in reclamation a good 20 years or more. And it's kind of a classical risk assessment and risk mitigation phased process. So the first phase, the philosophy is that in our basins where we have our dams, basin conditions or infrastructure conditions could be drifting, could be changing, and they want to look at changing conditions or hazard-related conditions every so often. So they have been on a 6-year cycle. I guess I was correct. I think they moved to an 8-year cycle from Denver, but I don't know if PN region has a different cycle. There might be some variations. But there's a recurring, call it a shallow depth risk assessment, gathering more recent information on conditions relevant to the integrity of the structure. So a key one that's relevant for climate is hydrology. Is there evidence that big flood conditions are changing in the basin? So this recurring facility review, this shallow depth risk assessment, if it flags some potential changing hazard conditions that are unacceptable, that kicks off a deeper dive risk assessment called a detailed issue evaluation. Really, it's a confirmatory risk assessment. So they're going to spend more time, more resources to look at this more closely, more sophisticated modeling and analysis. And in the end, if they judge that yes, there is an unacceptable risk here from hydrology or some other changing condition, then they'll kick off a corrective action study and look at the solution space. What types of corrective actions are on the table that could shore up the safety of the dam? And that's basically the goal there, is to mitigate the risk to some acceptable level. If the issue evaluation says, no, actually, it's not clear that there really is a unacceptable risk here, they'll do no action at that time, continue to monitor, and then they'll loop back to the beginning of the cycle. So they'll hit this every 6 to 8 years at minimum. So this process, how is it potentially connected to climate change? Well, clearly the big connection is going to be on the wet side extremes. And up on the upper left, I think we have a mistake. These bottom boxes of water temperature, water quality, they should be dashed. I just meant to solid outline the rainfall and the flood change possibilities. But we could have, if anything, I could have put solid outline around air temperature change and snowfall change to the extent that some of your facilities may be in snowmelt dominated basins, and some of your big flood risks may be tied to snow hydrology. It's for some of our dams, that's a possibility. But anyway, the types of climate that's relevant, change in heavy precip patterns, change in flood possibility, and those are among others. And considering climate change going forward, kind of a common message, I could have said this for all the communities, you need to judge what types of climate change are relevant for the given flood mechanisms at that given dam. So some of your dams, like I say, may be in snowmelt dominant basins, so you're concerned in maybe your past epic floods, if you want to call them that, or related to big rain on snow events, atmospheric rivers penetrating inland or something like that. Or other dams that may be different types of weather phenomena, more convective, thunderstorm, heavy downpour events during the warm season. So it's going to vary by site. So that's on this deciding what's relevant side. And then the next thing is judge what's reliable. What information of observed trends and future trends seems reliable enough to warrant some action in this risk management process. And also think about what can be practically addressed. So maybe science is immature, or for some levels of analysis might be mature. And so to help navigate those types of considerations, I would invite you to reach out to the Technical Service Center Flood Hydrology Group. They're trying to work on these issues, and I have some slides about what they're doing in Talk 3. Okay, we have one more slide on dam safety, and this is focused on activities in your Pacific Northwest region. Do you want to say a few words about this?
Yeah, sure. This is kind of an inventory of the efforts that we have in PN. We have kind of 3 levels of evaluations that go on a comprehensive review. All 3 of these have a hydrologic hazards analysis, which is an HHA, and they have varying degrees of climate change analysis involved. So the comprehensive review is done for all 57 of our high hazard dams on an 8-year cycle. We currently have 3 issue evaluations going on at Grand Coulee, Deadwood, and Island Park. And I think Levi might talk about a pilot study in Talk 3. We don't have any scheduled for PN yet. That'll be a more detailed level.
So in that middle column, under the yellow text, climate change analysis, are you saying that PN staff are?
Yeah, we currently do a simple kind of screening level climate change analysis for the first 2, and scenario modeling is involved with the last.
So I think it would be good for the staff in PN region who are working on that, maybe to connect with Joe Wright and Technical Service Center, and I'll prompt Joe when I get back. But, and he's listed as a contact in Talk 3. Because their pilots are situated in other basins, so it'd be definitely good to pool what's being learned in your Grand Coulee, Deadwood, and Island Park pilots. Okay, move on to the last community, Reservoir Operations. So we're focusing here on the group of folks that make day-to-day, week-to-week, month-to-month decisions on how much water to keep stored in the reservoirs, and also how much water to release from these reservoirs. So in making these decisions on storage and release targets, they're doing a really sophisticated balancing act, as I think most folks know. And I'll pause. Who here works on short-term reservoir operations? We have a few people. And so what I mean by this balancing act is they're trying to balance these considerations for multiple management objectives. So we use our reservoirs to provide flood risk reduction, or flood controls, sometimes we call it. We support environmental stewardship with our water releases or kept pool elevations. We have water quality goals, water supply reliability goals, hydropower generation goals, recreation, navigation. It's a long list. And the mix of these objectives is going to vary by reservoir to reservoir. The priority rank of these objectives could vary. So in deciding on storage targets and release volumes, the operators adhere to constraints which are mapped to these different types of objectives. So I mentioned an example constraint before. With respect to flood control, at many of our reservoirs, we have these calendar monthly storage ceiling diagrams, call it that, or the flip side is how much storage empty space do we have to keep in the reservoir to make the reservoir available to capture storm runoff and mitigate flood risk. So constraints are going to vary by reservoir. So given that they have so many different management objectives and associated constraints, I've highlighted all those hydro weather conditions, all those regions of interest, all those condition timeframes of interest, because for regional multi-reservoir systems, they tend to all come into play at some point. So this community is dealing with a wide scope of potentially relevant climate changes. Now, as they consider climate change, the key question, just move down to the last major bullet in this first sub-bullet, the key question that is challenging the short-term reservoir operations community is, when is it time to start updating criteria? So this question is fundamentally different than what the long-term planning community entertains. So like the Yakima Basin study, for example, they looked at, in their crystal ball, they looked at 30 years or more, what were the potential supply and demand gaps 30 years from now? Okay, there's some gaps, we have vulnerabilities, so what can we do about it? And they come up with strategies that would conceptually need to be in place 30 years from now to shore up those gaps. But getting from today to then, the question is, when do we start? If one of the strategies involves nudging our operating criteria, when do we start nudging? So that is answering that question requires these short-term reservoir operators to do that last sub-bullet, consider observed climate trends, consider near-term projected future climate trends, and reconcile them. And where they are in agreement, maybe there's good evidence that we're in a drift, and it might be good to start thinking about a criteria nudge. In which case, if that's the case, then probably need to interface with long-term planning. And I have a slide on that, and there's some pilot activities that are being led that PN region's involved with, but as are all the rest of reclamation regions, that they're trying to figure out a way to address that question there at the end. As climate changes, when is it time to update criteria? One very important preliminary report that came out of PN region that all regions group has considered and is influencing their approach is a report that was led by the region office, River and Reservoir Operations group. Ted Day, I think, was the lead author when he was still with that group. And in this report, they just focused on expected future climate conditions and tried to flag potential reservoirs and reservoir criteria that might be more, vulnerable to needing updated as climate changes. So this is a useful information product for folks who are interested in trying to identify reservoirs in your region that may have criteria that may need to be thought about as climate changes. So to summarize, looking across the communities, hopefully it's evident that there's several types of climate changes that are of common interest across the communities that maybe motivate sharing of approaches. So like how do we estimate potential changes in floods, or there's interest in changes in air temperature amongst all the communities. And also from region scales, reservoir basin to local catchment, condition timeframe, seasons to days. So making assumptions about changes of these types is pretty common across the community, so hopefully there's some conversation. For other types of changes, the interest is going to vary because the relevance of these types of changes is more community specific, so you might have more community specific approaches, which is fine. But lastly, hopefully communities feel inclined to share about how they're dealing with future climate uncertainty and dealing with that kind of a risk-based approach, that defining a cone of possibility and characterize it in a way that's practical for your planning efforts. So last slide, this is just a repeat of those preview messages. To summarize, we've always dealt with climate variability. Our challenge going forward is how do we prepare for potential drifts in that variability? So new floods, new droughts, or reduced expectation for old floods and old droughts. Management of water and related resources involves many considerations. Climate change is just one additional consideration, one more to the mix. And lastly, our response to the challenges posed by climate change, it is about preparing for the future and factoring climate change into our traditional approaches. It is about different communities communicating with one another. It is not about abandoning everything we have been doing, it's about flexing our approaches we have today just to accommodate one additional consideration. So with that, we have time for questions. Or digestion. So as you're thinking about questions, next talk is going to orient you on a range of tools that are available now or will be available shortly that you can apply in your different community activities. And we'll also take a 10-minute break before I start the next talk. But
I guess kind of a real simple question here is that the dam safety pilot, and it sounds like it's a very similar pilot to what we're looking at on the operations side.
yep.
Is there a chance to kind of integrate these types of pilots in the future to say, all right, we're looking at an operation flexibility and dam safety and infrastructure? Because, and I think back to that picture from the previous presentation, the cool cartoon that talks about, you mean it's all a hoax? You mean we improved our facilities for nothing, or the way we do business for nothing? I mean, they're all related.
Yeah, so I'll have a slide in the next talk that orients folks in the room about what those dam safety pilots are, but just to briefly preview, and I'll go back to the dam safety slide. Much like PN region, the Dam Safety Office and the Technical Service Center Flood Hydrology Group have conducted 2 pilots to address the first 2 stages of their 3-stage risk management process. So the first pilot was to come up with a preliminary method for considering changes in monthly runoff, projected changes in monthly runoff in their hydrologic hazards analysis. The second pilot, it's focused on Friant Dam in California. Friant Dam is in the Southern Sierra. It's a heavily snowmelt dominant basin. A lot of their big floods are due to atmospheric river possibilities, and particularly atmospheric rivers causing rain on snow to punctuate floods. So that what they've learned with their issue evaluation method there, it's going to be applicable to similar types of basins, but they also have other pilots planned for dams in other basin types. Like the next one they have planned is Taylor Park Dam in Colorado, which is near the Continental Divide. Its big floods are not necessarily due to just rain on snow, and definitely not due to atmospheric rivers, but they are due to big, heavy thunderstorm possibilities. So I'll have some more information on that. Back to Eric's question, how do the lessons learned in the dam safety pilots, how can they be integrated with the lessons learned in the reservoir operations pilots? I think that's remained to be worked out, but a key opportunity is how do you hold two pieces of information, reconcile two pieces. One's the historical observed information, observed trends, recent past, and how do you regard the future projections and make sausage with those two? So both groups are going to be, that's something I think both groups can learn from one another.